Kelly van Lancker from Ghent, Brussels.
Thank you. First of all, thank you for having me. It's an honor to be here surrounded by people I really look up to. So I will talk today about some work with Simon Steele, who's also at Ghent University, and more about the title later on. A disclaimer, I have been a bit ill, so I don't know how long my voice will be able to do this. And also some people might have seen it, but I guess the people who have seen it before also know that I haven't really had the time to do research in the last few months. This is it, John? Yes. Okay, this should do it. So we'll be talking about this paper. It's a paper in statistics and biopharmaceutical research, but I will talk a bit more later on how it was developed in the last year, because there is a bit of a story behind it. So it's chasing shadows, how implausible assumptions skew our understanding of causal estimates. And you might already have seen that it might be a little bit of a more critical talk. So you all know many of you are working in causal inference or have a link at causal inference. So our daily job really is about chasing causes, trying to find causal effects, etc. But I guess you also know that sometimes we have to make assumptions for that, and sometimes it might go a bit wrong in the sense that sometimes we will just be chasing shadows because of the misleading assumptions we are making. I don't know whether the pointer works or not, that's why. So now it works.
There's a bit of delay.
There's a bit of delay, okay. So then this slide, I already said it might be a bit of a critical talk. Of course, it's not a critique for causal inference, so nothing really has changed. I still like causal inference. As I say, holds for staying. So this is in no way an anti-causal inference talk. Rather the opposite, but let's see what you think about it. So what is then my goal today? Instead of having an anti-causal inference talk, it's really to show you that sometimes implausible assumptions are made in the literature and that they can be misleading. I will give one main example, but of course there are other ones, and Vanessa, for example, also has been involved in some work where we are discussing this. So what I hope is that we stop making these mistakes and that we can improve also on applied research doing that, so that people are also stop making this in practice. And then, of course, given that we are here with many people in causal inference, I would like to be the discussion. That would also be good for my voice, and how we can prevent this in the future. So first some introduction, and I will go over an example, and then I hope to have a short conclusion and hopefully a discussion with you on how we can get this better. So I guess you all know causal inference. You all know that we have like different frameworks in order to target causal effects, and one of the frameworks is a causal roadmap. So we started translating our scientific question into a model-free estimate, and that might seem obvious, but most of my work is in clinical trials, and I guess also the same, of course, holds for observational studies, but till a few years ago, people were not first defining their estimate. That's only in more recent years, because of FDA guidances, because of starting to believe in the causal inference framework, that a change has happened. And after that, we will identify our estimates. So we will try to link our quantity of interest to the data that we have observed, and we will try to be also clear about the required assumptions. And that, of course, is a very important step, although in practice, I guess, often overlooked. And then we have the estimation of the estimate. So this is, of course, obvious for many of you, but just realize that for many people, this is not the case, that we have, there are, of course, more steps in practice, but that we have these three main steps, and that the estimation only comes at the end. So what has been done in the past is more that we would start with estimating parameter in a model and not defining that in a model-free way. So I will come back to this causal roadmap later on to say what we think that might need to be different in this. So that's a big step forward, but there is a small but, I would say, in the sense that this is nice, this causal inference tradition also of stating our assumptions clearly. And I guess that's something we do really well. But in practice, I would say that we rarely critically assess them. And by we, I mean people developing methods, but also in more applied papers, you will see that people just will assume, they make the assumptions without really being critical about them. And I think one of the main reasons there is that he not always understands the assumptions. We often write our assumptions in the quadrifaction framework, quite a powerful framework, but it's also quite complex because there is some mathematics behind it that can obscure unrealistic assumptions, as you'll see later on in the talk. So if you would fall asleep, or if my voice will not be able to survive till the end, then I hope that you will remember from this talk that the choice of our estimate should not solely be based on what we ideally wish to learn, but also what is feasible to learn. Which assumptions do we need? And are these assumptions in any way realistic in practice? Okay, so now I will go over an example by some influential people in the pharma industry. So it's mainly about this paper, but some of the assumptions also have been used in other papers and are quite widespread in the pharma world at the moment. So how did we come to this paper, and why did I not pick another paper where they also make assumptions that are probably not plausible? We just identified it while doing consulting because a certain pharmaceutical company wanted to use this method as written down in the paper with the assumptions that we were making. And as I already said, some of the names of the authors of this paper are really influential, so this methods are often used in practice. So our idea was more Steen's idea, to be honest, because it's he who came to me. We just wanted to write a letter to the editor about this paper, but while we were writing that, we informed the editor of the journal, and then they actually asked us to expand it to a larger piece. Nevertheless, you will see that it's still mainly focused on this paper for that reason, but just know that there are other examples in the literature, many other examples. So here is the example we are using. So it's the Imagine treatment. It's a 52-week phase 3 trial. Not super important for now. It's actually mainly to introduce some notation. When we compare an experimental treatment, we'll denote that by t equal to 1 with a control, which I will denote by t equal to 0. So it's a trial for type 1 diabetes. I also have adherence. Again, binary. I will talk about that a bit later on. A equal to 1 means that my participants stay on treatment. A equal to 0 means that he will discontinue. And y is my outcome. Again, not super important for now, but it is binary, continuous, etc. And so the type of estimate we are focusing on is principal stratification estimate. So we are interested in an effect for a patient who would have adhered no matter what treatment they were taking. Yeah? So they would adhere under the experimental treatment and also adhere under control. So we would write it down in counterfactual notation as follows. So we are interested in the expectation of a counterfactual outcome under treatment minus a counterfactual outcome under control in this specific population that we cannot observe, adhering under both. Their main aim is actually quite an interesting one. One of the limitations of principal stratification methods is that it's quite a challenge to include time-dependent confounders. And so their goal is to adjust for that, to allow for correction for time-dependent confounders, which I will denote by L. Okay, so now I will show two assumptions that were written down in this paper, among others, that we also cite in our paper. And I will say why we do not really believe that. So I already said that we assume that we have access to longitudinal data L, but they also assume, of course, that they have access to baseline covariates, and these will be denoted by X. These are two assumptions that we make, actually two times the same assumptions, just changing the treatment here. Clearly say that the counterfactual adherence status under treatment is independent of both counterfactual outcomes and the counterfactual longitudinal data intermediate outcomes under control, given our longitudinal data, counterfactual longitudinal data under treatment and baseline covariance. Of course, also the same if we switch the treatments. So, although we are all familiar with causal inference, at least I had to think a bit about it when I saw this, like, what is exactly written down here, okay? We just realized that these are methods that are then used by trial statisticians, for example, without really realizing what's written down there. So my question is, what does this mean? Could this be plausible? I guess you already know what I will say later on. I will only focus at the moment on just a part of this assumption. We'll take out this, namely the adherence, counterfactual adherence status under treatment being independent of our counterfactual outcome under treatment, given longitudinal data under treatment and baseline covariance. I will show another assumption later on, and actually these two assumptions together tell us also something about this whole assumption. So they refer to this assumption as an ignorable adherence assumption. And we translate that as, or give that an interpretation as, adherence only depends on observed values X and longitudinal data under treatment. So I would already say that that's not the best thing to say, but also the fact that they give it a label ignorability, and we have seen that a few times in the literature, is a bit misleading, I think, because if we talk about ignorability, that's something, or exchangeability, something we often use in causality or in missing data, if we talk about missing at random, etc. So giving it that label to us actually seemed a bit misleading, suggesting that it is not less plausible than a typical ignorability of Marr assumption. Okay, so that's something we thought, but happy to hear what your opinion is. To give it such a label is quite a smart thing or a bad thing to do, because it's actually suggesting that it is as plausible as the other common assumptions that we are making. But of course, the standard ignorability assumptions looks a bit different in the sense that our treatment indicator will then be independent of our counterfactual outcome under treatment or under control, given baseline covariance. Of course, one big difference between these two, and I will come back to that later on, is that here we have our treatment indicator being independent of our counterfactual under treatment. So we have two times this treatment in here, but also in our counterfactual that we wanted to be independent of. And this is of course not the case here, because our adherence status is not popping up in our counterfactual outcome. So that's the big difference between these two, but I will come back later on because that will also be the solution. So is this assumption indeed plausible? So I will argue that this perceived plausibility is a bit misguided. So if I just use some basic math and I make use of the fact that we are in a randomized study, so we make use of the randomization, then we can write this as observed variables. And I can just say, okay, after rewriting, this means that adherence is independent of our outcome given longitudinal data, given baseline covariance, and in this case now in the treatment arm. So for participants who were assigned to treatment. I would say this is much less obscure. So what does this actually mean? I'm just comparing two groups of patients. Patients with the same baseline and intermediate covariance in both groups. Both patients groups also got the experimental treatment. The only difference is that in one group we have poor adherence, and in the other hand, other group we have good adherence. And the assumption here is actually saying these two groups, same in baseline, same in intermediate covariance, same in the treatment group, only the adherence is different, that they have the same outcomes in distribution. I would say that's quite a strong assumption, given that we are interested in testing a new treatment. So you would want that adhering would make a difference. So I'm writing a diagram here, not a complicated one, in the sense that even assuming there is no unmeasured confounding, etc., etc. So it's just a simple diagram. And what are they assuming? They're actually assuming that adherence has no causal effect on our outcome. Okay, so that's if you translate the assumption, yes?
Can you just, you can just check it in the data.
Sorry, can you just
You can
check?
just check, but you can just check it.
Yes, that's also.
You can-
Yeah.
So this is why you do these things, and then you say it's like.
Yes, but
Yeah.
also, if I would be developing a treatment, then I would want the treatment that the more I adhere to it, the better my
Yeah, I
outcome.
agree.
So it's
Certainty it's even a testable assumption.
yeah, probably. I haven't. Yeah, probably. Yeah.
No, but you can look at their table and see.
Yeah, whether there is a difference. Yeah, sure. Yeah. So doesn't it make sense, I think, if you're developing a treatment to make such an assumption. You can also write it in a diagram if that would be more clear. Okay, so what's the solution? I actually already have set a solution. It is, of course, a simple solution. You can say, and if I bring this talk to an audience less familiar with causal inference or similar talk, yeah, then they will say, oh, that's simple. I just add in my counterfactual an adherence status there. So that's what he needed to do. That's also what we said in our letter to the authors, to the original paper, but it became a discussion paper. So meaning that he could answer to our letter, and what did he say? He said like, oh yeah, okay, fine, we forgot to mention the adherence status in our counterfactual outcome, but that's no problem. It doesn't make a difference for our estimation approach. Well, of course, it makes a huge difference, as we will see later on. Okay, sorry. So it's not really a minor detail, because if you look at the estimation approach, and I can tell you this is only one part of the estimation approach, there are also changes somewhere else, it will make a difference. So in the original paper, you need to model at a certain time the expectation of counterfactual outcome under control or under treatment doesn't matter, given baseline coverage and this longitudinal data. While if you would follow the right ignorability assumption, then you would actually need a model for the counterfactual outcome under certain treatments, but also under adherence. Yeah, that you stay on the treatment. Yeah, this is easy to estimate. We just estimate it, sorry for this, by regressing our outcome on the baseline coverage and longitudinal data among patients who got the control, and of course the other way around if you're interested in under the experimental treatment. But adherence does not play a role at all here. Okay. Here, on the other hand, we built the same model, but only in the participants who adhere. And of course, that model can look completely different whether you are only looking at a subgroup of patients who adhered versus not. So that's what he needed to change. I haven't checked how much difference it makes in your conclusions, but I can imagine situations where it would, or that's at least what I would hope if I'm developing a treatment, that it will make a huge difference. So how did it end? Because it was a discussion paper, there was also, we have written a rejoinder where we have pointed this out. And then there was also a discussion, an online discussion, where everyone has given their presentation. So we started and then we had commented on us. And although I had said in our presentation, like it makes a huge difference for the estimation approach, the answer in there, or one of the first slides, they were saying it does not make a difference at all in the estimation approach. So I don't know that he never read the rejoinder or so, but at least I had said it 10 minutes earlier. So they are not really admitting that it makes a difference. Okay, another assumption, which we call misguided cross-world independencies. I guess you all know that once we are working cross-world, assumptions anyway become a bit less clear. So one of the assumptions we make is that the longitudinal measurements under treatment are independent of the longitudinal measurements under control, given baseline covariance. Similar assumptions are often made for adherence status under treatment, being independent of adherence status under control, given baseline covariance. Again, what does this mean? Is it plausible? I guess it's more difficult to understand given that it involves two worlds, but you will see that it's easier also to come up with some settings where it would be completely violated. But first, a bit about this assumption in the literature. Again, you will see similar authors over the paper. So this is one of the first papers where they are using this assumption, and there they say, okay, this is a very strong and untestable assumption. If we go then further in time, a few years, then we actually see that we still note that this is a difficult assumption to evaluate, but they do not address at all the plausibility of the assumption, so they just use it. And then in one of the last papers, 2023, 2022, they say this is not an unreasonable assumption. So just know that some of the same names are on these papers, despite the fact that it's natural correlation. So I guess it's in this paper that they try to assess that using like a crossover study. But of course, yes, they are then trying to test this assumption or trying to test whether there is a difference or not between these two, but they are trying to prove the null. And one of the first things I guess we teach our students is try not to prove the null, because you might have a completely underpowered, that also depends on your power, etc. So it's a bit a strange thing that we did there. We also have commented on that in our paper. Okay, so we think this is essentially impossible to hold and should not be used at all. And I will give 4 reasons for this, but happy to hear some other ones. In general, the assumption, like it's written down here, if we assume Pearl's non-parametric structural equation model, you can write it down and you would actually see that it requires that X, so our baseline covariance, captures all prognostics factors of our longitudinal measurements, under treatment and under control, which actually means that X, our baseline covariance, need to predict our longitudinal measurements perfectly, of course, again, up to some noise. So that would mean that adjusting for longitudinal data L, beyond our treatment, of course, would add no value. And that's, of course, a little bit strange, because maybe you remember at the beginning of my presentation, I was saying, I like the aim of their work, namely trying to adjust or correct for time-varying confounders. But by making this assumption, you're actually ensuring that you will have no added value at all. Or at least that you believe that you have no added value at all. Okay, second concern, and hopefully you just like one of the concerns, that's enough. I will assume that treatment has no effect at all. Okay, this is a really strong no, but just to make it a bit clear. And in general, it will then also not impact my longitudinal data. Okay, so I really make a strong null assumption, or I'm under a strong null hypothesis. Of course, if I'm under a strong null, that would actually mean that my longitudinal data under treatment and under control are exactly the same. Okay? Yeah, of course, if they are the same, that would definitely violate the assumption that they are independent of each other. We would say that this is a serious concern, and it's one of the things I learned from Els and Snijder is always that analysis should not be invalid under no treatment effect. So from that perspective, I think making this assumption is quite strong. Of course, I'm here assuming a very strong null hypothesis, but even under weaker nulls, I guess we can believe that this longitudinal measurements under the control and under the experimental must be quite strongly associated. Okay? Third concern is a link to longitudinal measurements, and just in general, if you have repeated measurements L1 and L2, so measured at time 1 and 2, for example, 6 months, 12 months, just 2 repeated measurements. And what we usually don't want to do is assuming conditional independence between these two. So if we would do that in a repeated measurement analysis, I guess many people would not allow us to make this assumption that our longitudinal measurement at month 6 and at month 9 or month 12 are independent. Nevertheless, if we would make that assumption in a repeated measurement analysis, it will not will only affect our standard errors, not introduce bias, etc. However, if we make this assumption here, then I would first of all say that this is less justifiable, because here these both measurements, these longitudinal measurements, are measured at the same time, not 6 months apart from each other. They are, for example, measured after 6 months, both of them. The only difference is that the participants got a different treatment. This will affect our standard, not only our standard errors, but will also introduce bias in our principal stratification effect. So the consequences are also much bigger. And then the last concern, and I think from a causal inference perspective, we can all appreciate it. I guess we all know that usually if you think about known measured confounders, if we go to the clinicians, we would say we need to measure as many covariates as possible, variables as possible, because that will make our assumptions hopefully weaker. But here is the opposite, in the sense that as more post-baseline covariates become available, our assumption will become stronger. So the more post-baseline covariates longitudinal data we have, the stronger the assumption will be. So this, of course, again, a bit against the aim of the paper, may discourage people to adjust for longitudinal measurements. May discourage people to adjust for our baseline, for our post-baseline covariate study. Okay, so this is in contrast with what we usually try to do. We try to reward rich data collection, but here it's the opposite. Okay, so then some conclusions. So I hope you don't see this as an anti-causal inference talk. We'd also say many of these people are unknown to you if you don't work in clinical trials or in the pharma industry. And I still think that it is a powerful framework, and it's very welcome also in the clinical trials literature, in the pharma world itself. But it also comes with a bit of a risk, as you have seen today. People might misuse the causal inference or counterfactual framework to come up with whatever assumptions they want. And we might be overambitious at what you want to estimate, what you want to target. This is an example. One, there are many in the literature. Like I said, Vanessa also has been involved in this paper, I guess, which is also commentary on another paper on mediation. So it just reveals that there is a danger in using the language, and that it enables us to make assumptions that have no biological sense. Doesn't mean, of course, that we shouldn't use a framework. I just think we need to be a bit more careful before we will trust everything. So I think it's first of all a result of asking overly ambitious questions, and that brings me back, and I'm happy I got here, to what I said earlier. Our estimate should not solely be based on our ideal question, what we ideally wish to learn, but also on what is feasible to learn, namely under plausible assumptions. And for that reason, we thought that, it would actually make more sense if we adapt the causal roadmap, and in this step 2, also add something about judging the plausibility of the required assumptions. And if these assumptions are not really plausible in practice, it might even be an assumption that is plausible in some settings, but not exactly in your clinical setting, then you should go back to this first step and just try to come up with another estimate. Now, this is also in a paper of Dang et al. From 2023, we discovered later on. So we should judge our assumptions, and I think we, in the first place, as people developing causal inference methods, because if we already downplay our assumptions, then applied researchers, applied statisticians will do the same thing, I guess. And that brings me with some questions. So how can we better lead by example? How can we better show what the assumptions are, what they mean in practice, etc. But also, how can we ensure these critical messages? And by these critical messages, I really mean what I have said today. I would say it's a critical message. How can we ensure that people will take that seriously? As I said, we had this whole event on the discussion of this paper, and then they still say like it doesn't change anything. Yeah, for me, that was one of the biggest disappointments in my career so far. That people didn't see that. Also, these of course still have a big impact, and that's fine. But then I saw a few weeks ago a course on causal inference for pharmaceutical companies taught by these people, which is fine, but probably they are again showing this method, showing these assumptions. I don't know, so I will not say that's the case, but if it is the case, then I just find that a bit dangerous practice. At the same time, as we were writing this, it was already on archive, I guess, was reviewing a paper that was using this method. And I said, yeah, I cannot really accept this. And I fought a lot with the editor, but in the end, the paper was published. Okay, so just to say that like the message is not really taken so seriously. Not that I say that you always have to take me seriously, but I just mean like I just hope we can do something together. But I also think there is a role for the apply statisticians in the sense that if they go to the clinicians, at least to me, no clinician has ever asked me to target a principal certification estimate. But and there are settings where it might be useful if you think about application by that, etc. And there is no real at the moment, no real other solution for that. But some people argue that their clinicians are always asking for this estimate. Then I think, yeah, that's maybe because you are advertising it and saying like, okay, well, we don't need strong assumptions. So I hope we can like, and it's of course difficult because we all want to promote the methods we like, that we can like be honest with that and not oversimplify the assumptions we need and be clear to them. These are the assumptions. It's quite strong, so maybe we should target a different estimate. Just shortly, like of course, I've given the example of principal certification because it's an easier one in the sense that we have these cross-world assumptions. It's easier, I would say, in the sense that it's easier to make mistakes, and I have said easy 3 times in one sentence. But I think for me it's still difficult to see in many settings why it is relevant, how it can be used, especially for decision making, because we don't know who belongs to this group and definitely not whether it even exists. And on the other hand, this framework is not ready for handling intercurrent events because of its inability to just propose baseline covariates. And something I already mentioned in the beginning is this binary adherence status. You just have to think this adherence status means have you adhered during the trial, yes or no? I guess there are some gradations in that, some levels of adherence. But also the timing is an important part that was taken into account very well in Jack's example, but is not the case here. And I think dynamic treatment regimes might be a solution for that, but maybe we should stop here and Mats and Oliver have written a nice paper on that also as a reaction to one of the papers in the clinical trial strategy. So happy to have a discussion and especially hear your opinion on how we can play a role in this. So thank you for your attention. Thank you. Thank you. We've got some questions, I think, so let's be first.
Really nice talk. So the first part of the assignment you talked about sounded like they're effectively assuming the null. So is their method like even powered to detect anything? Did I understand correctly?
You mean in the yeah, I don't really go back.
The testable assumption.
It's you mean about this adherence having no effect on the outcome? Is that the one you
Right.
mean?
Yeah,
Yeah. So that's what. Yeah.
there isn't, that's right, there's
That- that-
assuming that it has no effect on the outcome, so that's.
Yes. Yeah. Yeah. So that's what I meant.
I
Like.
mean-
Yeah.
If, I mean, does that mean that their estimand is identically zero under this assumption?
It's no. Yeah. It's the adherence. Nevertheless, if I mean.
Oh, you're not.
So the
you're not
estimate.
Making the exclusion.
Yeah. Yes. Yeah. So.
You can think about it.
Yes,
right?
but-
That's why you can test it.
Yeah, I mean, I guess you could make like another, I mean, I feel like stop, they're already dead, but another argument you could make. That might be more compelling is that like, suppose that they're, you know, all of the effect is through adherence. Then
Then yes,
using their
yeah.
methodology, you would never find anything.
No, exactly. Yeah,
So-
yeah. So, I mean, if you really believe this assumption is true, then it does not matter whether you have taken it at all, right? So,
So from the perspective of people who want to get their drugs approved, they would not want to use this, right?
Yeah,
They would
yes.
want to detect things, yeah.
Okay.
sorry.
Do you think any forms of pre-registration of the analysis protocol will help or not? Because there has been some other discussions from people doing artificial animation, arguing that there shouldn't be that a predetermined pre-registered protocol. Exactly due to that, there may be some, you may have some issue after getting into the data and feel like your original estimate that you propose is not estimable or have so strong cost assumptions that you need to know. And you will have to adaptively update your cost estimate or target or something like that. But there are like some issues, for example, you can be so cherry picking, right? But I just pick the cost estimate that has a significant result.
Yeah, I mean,
Yeah, and how do you think about these issues?
I mean, yeah, in the trials world, of course, everything has to be pre-specified, and it's always a fan of that. I mean, when it comes to your estimate, I'm definitely a fan of it. Not about other things, but we can discuss that later on. But yeah, defining your estimate after seeing the data, I don't think is the best thing to do. Now here it goes further in the sense that I even don't need to see the data.
Yeah.
I know that this is violated in many settings.
So sometimes you only know it's
Yeah.
so impossible after seeing the data.
Yeah, sure, yeah.
Yeah, so I guess there's still some tension in between.
Question about
Nice. I guess I'm just wondering, so I thought about this too, about how do you make this avoid these sort of issues, and to me, I think it's less about, or I wonder if it's less about an iterative roadmap based on assumptions, and rather sort of a shift of the culture that we really do have to do more work at the top of the roadmap, because my diagnosis was we sort of got into sort of coming from the culture of statistics, there's a desire to sort of slap a counterfactual index on only things that are measured in our data. And if you really sort of draw out a story of, like, I would want to know why do they care about that thing? And if you really push a clinical story on that, I don't think it would be framed in that way. And you would have, because we don't know who's going to, we don't know this crossroad. So if you think about what decisions is this trial going to lead to, you might end up with something that is actually, you could call it an ideal question. And there still might be problems with the data in asking that ideal question, but I don't think we should discourage asking those ideal questions. If we do that honestly, then that leads to like better data collection before we do this trial, right?
Yes, I mean, it's not that I would not want to target the ideal question, I guess. And I'm sure, there are settings where I mean, there are assumptions in the principal certification world that are more plausible than this one. So then you can still use these ones. For me, it was more here that like the assumptions they want to use, yeah, are quite misleading and probably not plausible. But I agree, if there is a setting where we can still do it under reasonable assumptions, and even then if you see the data, it was not great. I mean, I would say, I'm not making myself clear, but if we can target the ideal question, then I would still do that, of course, but hopefully plausible assumptions. Question?
I fully agree with the main message of your talk. I just want to add remark to the adaptive roadmap. You presented, I just think if we go to like deviating from the estimate we had in mind originally and go to other estimates, there's just one caveat. And I think one example there from instrumental variables where I think one of the motivations to introduce this whole late framework was exactly what you said that assumptions are not plausible. We need to target alternative estimates. What happened now is that people just apply this late framework and then all end up interpreting the estimates again, sort of in the as the average reading effect. And I mean, you're completely right. If we make sums that are implausible, it's not of much use. But if we make inference on estimates we're not really interested in, people might just end up making implicit assumptions when they're translating into decision making.
Okay, yeah.
It essentially becomes the same issue. So one is not better or worse than the other. I think it's just something that has to be kept in mind. And it might be too easy an answer to just say, or I feel like as methodologists, it's just easy to push off responsibility to the people who then have to interpret their estimates.
Yeah, that's a good point. Never thought about that you would then make still the wrong translation maybe in the interpretation. Yeah, thanks.
So I think people already do this because otherwise they wouldn't do a target trial. They would just target individual level effects. But they know that there are certain things they cannot identify. So already by doing a target trial, they commit to things not being identified. So the question is where to stop. And the other thing is, here we say we want identification, but Erin would say she wants balance. How do we? And also too, so in some sense, for Luca's comment there, you can report a local average treatment effect if you believe in those sort of assumptions, but you can also say what are the bounds of my average treatment effect? You can report both, at least you're closer to something. In the sense that I think people already do this trade-off, maybe informally, but it's very hard to formalize because it depends on the question.
But do you think that is like, I mean, you know this, other people in this room know this, but do you think this is already something we can expect from?
I think your examples are shocking, they're really good. But the pharma, I just feel that this is a failure of science more than anything. That they can live in their own bubble and make assumptions that we are, they can call that as completely insane.
Yeah, sure.
But the problem is that they're not engaging with the field. They're writing their addendum without having a single causal inference person involved, right? So it seems to be more of a structural problem.
Yes, definitely. Yeah, there are a couple of questions.
Really nice talk. I was just curious how much do you think this has to do with like a social engineering thing as well as like, do they have, or maybe even a software engineering thing, like do they have an easy to use package for their method? And I've been very pro like developing nice easy to use software, but I think that also results in like misuse when it's just too easy to use off the shelf. And I don't know what balance we go for as people translating from theory to practice of like, I don't want to make my methods hard to use, but I also don't want it to be misused.
Yeah, I actually forgot whether they have a package now without giving names, and they are also not on the slide. What might be a reason of this is why they are not really trying to change anything, because if it were my paper, it would not be online anymore, I think. Is that some are involved in a consulting company, doing consulting for all big pharmaceutical companies in the world. So I'm wondering whether, I guess, so they are often implementing it for companies, so that's also easy to use, let's say. I'm wondering whether that's one of the reasons why they are less eager to admit that there was a mistake, because I mean, some of the pharmaceutical companies are now even saying like, oh, yeah, there is a fight between our consultants. But for me, it's not really a fight. I'm not a fighter at all, first of all, but also
You're right.
it's what Max is saying. There is something wrong here, and from a scientific point of view, whether I'm right or wrong, I think this time we are right, and I would want people to do the right thing. So regarding the software, I have to look it up, but usually there is quite some software available in this world, but I would also say that often it's done by consulting companies, and then it's also seen as trusted.
I think 2 more questions left into Limbo and then Jack. That might be enough.
I want to come back to this point between how plausible your assumptions are and how interesting your estimate is. Right, so obviously there are 2 extremes, and one extreme is people will not talk about any causal effects, and not too long ago in statistics we never talk about causal effects, we only talk about inductive association. Of course, and they think of all the causal assumptions being not plausible, and we should never talk. And at the other extreme, we also have this, of course, what's the ideal estimate would be the individual treatment effect, right? This is true of all the causal questions, and obviously there's no plausible assumptions that will allow you to identify that. So I guess I was just curious, I mean, we have to draw a line of, then it comes down to what assumptions you consider to be plausible, right? And I just curious about your take on this. So what assumptions, where do you draw the line, right? Do you think all components and measures are possible? Do you think IP are possible, or do you draw a line whenever we start to make plausible assumptions, then we think this is not possible?
Difficult to say here where I draw the line. I think I would just say that maybe sensitivity analysis here are the answer, and if you then go back to the known measure confounding assumption, etc., there are quite some alternatives there already, so we can already do that under different assumptions, different methods. So there I'm relatively fine with it. Nevertheless, I would still tell the clinicians to have as much data available as possible to make my assumptions more plausible. But I guess again, it's a really good question and a really difficult one. Yeah, for me, some of these it's not even just it's not realistic at all. That it's just wrong, and that for me is already a different one. But for me, it's also vague where I would draw the line of like plausible versus not. But I hope in the future we can at least, as developers, but also applied statisticians, be more clear about that. So if we develop new methods and we make assumptions, give settings where it would be plausible, but also give settings where it would not be plausible to make these assumptions. And then the next step is, of course, that the applied statisticians argue why they think it is plausible in their setting. But I also believe that they would need our help there to understand it.
Jack?
Yeah, I'll just stand up. I really enjoyed reading your paper, and I feel if you just go back to the diagram where you show the red arrow for adherence, I feel like what I would love to have, and I think what would be a great service to the field, is would be a tool to turn the very complicated statement of assumptions that involve potential outcomes, how you're able to translate that into an assumption based on observables, and then draw a graph like this. That's my plea for a bit of software, if anybody wants to develop that. Because I feel like if they could have seen the implications of their assumption straight away, they may have stopped at that point.
That reminds me that I have,
Yeah.
they actually must have seen it in the sense that, I forgot whether it's, it's a DAG, whether it was a DAG or the SWIG in their paper, but it is in it, right? Without the arrow.
Well, I was actually the reviewer for this book, and I asked them to forward that. But if you just go to can you go to the assumptions and I just show people the difference between your assumption and written based on observables.
Wait, you mean this
Yeah,
one?
this one, and then how it's written in there. I guess, yeah, so it's the top one. So, yeah, so kind of translating the top to the bottom with the that would be a great piece of software, in my view, to create.
Okay. I don't know.
I'm sure we could have. We've got multiple very people asking questions, but it is lunchtime, so I think that it is better to draw a line here.